Okay, I'll be going over the 2011 FRQ. It's AP Calc from the 2011 exam, Form B. Um, so to save time, I won't read this whole problem. I'll just go over the important things that we need to know. We need to know it's from 0 to 10, so those act as their bounds. Inside bounds of 0 to 5 and 5 to 10. The arc that is between 0 and 5 has the length of 11, and from 5 to 10, that arc has a length of 18. And the area in the region from 0 to 5 under this x-axis and bounded by the curve is 10, or it's negative 10 because it's under the x-axis, and then this region, or the area of this region right here, is 27. And that's pretty much that you all need to know to solve A, B, C, and D. So let's get started with A, which says find the average value of f on the interval from 0 to 5. So to find the value, we need to take the integral um, in general, and then for the average value, you need to also divide by b minus a, which in this case is, if this was a coordinate point or a bound, 0, 0, 5. This would be the A, and that would be the B. And that's just how you do any average of anything, really. So let's get started with A. Let's make this a little clearer. So A, finding the average value of f on interval 0 and 5. So here are my bounds, integral bounds being 0 and 5 of f of x d of x, and then, like I said, b minus a, 5 minus 0, because I have it one more time over here. These are the bounds 0 and 5 in a and b, and this is just what you do for average, like the average rate of change, which is basically slope. And then the integral of f of x d of x with 0 and 5 as the bounds is negative 10, because, like I said, on the graph, this region is from 0 to 5 is 10, and it's negative because it's under the x-axis. And that's the area of it. And then 5 minus 0 is obviously 5. Negative 10 over 5 is 2. Negative 2. And that's all you need for part A. Now, let's move over to part B. So part B gives us a definite integral, and bounds being 0 to 10. And the equation is 3 of x plus 2 dx. And a property that allows us to separate these two will actually make this problem a whole lot easier. So first off, we take this 3, put it in front because it's a constant, so we're not bothered by it. And I have separated, so what I mean is we're going to take the integral of f of x d of x, and then separate this and take the integral, bounds being 0 and 10, of course, of 2d, the second part of the equation. And then my 3 is still outside. For this area, what I've done is I separated 0 to 10 into 0 to 5 and 5 to 10, and I'll show you why in a moment. That's going to make everything a whole lot easier. So from 0 to 5 of f of x, and then 5 to 10 f of x dx, which is still 0 to 10. From 0 ends at 10. I've simplified this into 20 because 2d of x, the integral of that with the bounds of 0 and 10, just imagine it's like a rectangle. It would have the base of 10 and the height of 2, and the area of that would be 2 times 10, which is 20. So the reason for simplifying this that way is because this equation right here, this first one right here, gives us the area of, remember the bounds on the graph from 0 to 5 gives us the area, which is negative 10 since it's under the x-axis. And that's where we get the 27 as well, because we get the area. This second part gives us the area of that second region that's bounded by the graph and the arc, and it is positive because it's above the x-axis. So when you plug all that stuff in, you just do math, algebra, arithmetics, and you get 71. That's it for part B. Now let's go over to part C. For part C, it gives us g of x equals the integral of bounds being even x of ft dt, and it's asking us to find where it's concave up and decreasing. So I can say that g prime of x equals f of x because of the second fundamental theorem of calc, which basically says if f prime, or the antiderivative, works, in simple words, works in with f of x in a certain interval, then you can say g prime of x equals f of x. And so since we can say that, so we need to find when g of x is concave up, and then it's treating it like an f of x. So it's concave up when the prime of it, or the antiderivative of it, is increasing, which is from 3 to 8, which is from the problem itself, and it's also visible on the graph. And then for the second part, we can say g of x is decreasing when g prime of x is less than 0. So remember, on the graph, anything that was from 0 to 5 was under the x-axis, so it was going to be less than 0 because it's all going to be negative. And that's also from the problem. And then at the end, you just need to combine those last two statements. So g of x is concave up and decreasing on an interval from 3 to 5. And it's just combining this interval with this interval. And that is our final answer for part C. Moving on to part D. So part D is about arc length. So it's arc length from x equals 0 to x equals 20. Those become our new bounds, and we're given the equation h of x equals 2f x over 2, and h prime of x equals f prime x over 2. So the arc length is going to end up being the integral, the bounds given 0 and 20, and this is the formula you can find online of taking any arc length. So we have 1 plus h prime of x squared dx, and h prime of x is right here as well, and we know it's equal f prime x over 2, and therefore we will replace this with that, and that is what we have down here. And then once we get here, we have to go all the way back. We're almost back at the at f of x. The only way we can go back, however, or one of the easiest ways, is to use u substitution. So for u substitution, my u is going to be x over 2 because it's inside the parentheses. That's usually that usually works using whatever is inside the parentheses. And dx, of course, is going to be 2 du. And for x, when x is 0, when you plug in x over here, 0 over 2 is 0. When you plug in 20, 20 over 2 is 10. So u is 10 and u is 0. Equals 0, those become our new bounds, and the 2 comes from this 2. We just move it on the outside. Like I said, constants are just easier to see on the outside. New bounds of 0 and 10, and here's our formula from before. And this formula is this integral, this whole thing right here, is pretty much the 2 arc length. Like remember in part B, when the integral was the area, this one is actually the arc length, and it's given in the this is given in the problem. So the first one is 11, and then the second one is 18. This is the a to b one, and this is 0 to 5 and 5 to 10. And once you do that math, plug it in the calculator or do it in your head or on paper, you'll get 58. And that's it for number 4, Form B, AP Calc 2011 exam.